Hello. My name is Dan Bogos. I'm part of the CGRateS project. Many of you know us already. For those who don't, we are a company located here in Germany, in Bavaria. We cover both wholesale and retail business, and we try to focus and try to understand the real time. Actually, we are responsibly understanding the constraints of the real time processing. About CGRateS, it's a real time charging engine. So we don't do full billing system. We keep it on purpose in order to be pluggable into existing billing setups. We don't want to completely replace large investments into existing infrastructure. We are also, by doing this, we are also able to accommodate new components into our customers' networks. We are non-intrusive. We try to just exchange data with the switches, so we don't want to enforce traffic going on or flowing through us. We have a modular architecture. It's easy to enhance it by rewriting specific components, so you don't need all of them, or you want different logic, you can simply take some of the components and replace it with yourself, because we use APIs for everything what we do. So we got a large number of transports already supported. We do JSON, we do HTTP, various combinations, JSON over HTTP, then JSON over WebSockets, some Golang specific GOB serialization. Then we are performance oriented. We have our own built-in transactional cache system. Almost all the data which we use, it's cached, so we use as less disk as possible. The only part which stays in the database itself is the accounts for the bundles and such, the wallets. And this is for a reason, if by any chance something bad happens, the accounts are saved. But even there, we use database like Redis or Mongo, which are pretty fast and cached as well. We do everything what we do is asynchronous. We use microthreads. If you know Golang, it's very powerful in this area. We are feature rich. We got multi-tenancy from day one, derived charging, sort of session emulation, so you get a call and we fork it into thousands of others. You are able to bill in this way supplier as well as customer, plus other ways like various reseller chaining and so on. And also control this, so if one reseller is running out of credit, even when your customer have it, then we are able to detect that and kill the call. We do account bundles, unlimited number of balances, combination, data charging, SMS charging, MMS, whatever. LCR we support. I was talking last year about it. We do quality-based LCR, so we are able to combine classic as well as new ways of doing LCR. We have CDR stats, again in memory all, so you can do all the classic stuff, ASR, ACD, counting, all this stuff is built in. We have our own diameter server implementation. Regarding this, we have built it pretty generic, so we can support any diameter standard you wish. We have some processors which are configurable. You define in the JSON templates the logic which you want to implement in your own diameter. So you can use it not only for billing, but also to retrieve user properties or whatever you need in your diameter client part. We do the new buzz in the billing, a number rating, so we can bill based on where your user is coming from. We have lately built in high availability for clustering and such things. And we are pretty agile in developing new features. and we educate us towards that. We have a test-driven development project. We got today approximately 1,300 tests as part of our build system. Here you can see a bit of history. Since 2012, we were continuously increasing our code base. We are not always happy about increasing our code base. Actually, we are pretty conservative there, but this means for us pretty much the features which we have added in. Regarding performance, we are sensitive on that chapter as well. We provide our own binary for you to test and do your own estimations of load which you can take on your own tariff plan data. As you see there, internally we are able to process about 85,000 requests per second within the process, and from a completely even other programming language, we are able to do something like 4,800. That's worst case scenario of encapsulation. Of course, this also depends on what you use as your accounts database, whether you use accounts database and so on. Regarding the CDRs, we have a centralized CDR server approach. Of course, this you can also scale up. So if you want to split it, you can do that. We have more interfaces to that. So we have a real-time CDR interface. We support their free switch via event socket, then Kamailio via EVAPI, OpenShift via AV, and also the diameter server there. We also do offline CDR processing, so if you get CDRs from your suppliers or carriers, you can easily import them into CGRateS to do, I don't know, billing assurance. And then there we support CSV, we support fixed width format, as well as XML. These are pretty generic. You can define your templates, so you can just tell us from where to pick which information. So it's pretty dynamic, and also you can have your mediation rules built in there. So if you want to transform from national into international and all these rules, you can do within the CDR processors. Then we have also generic APIs for CDR feeds. If you have a platform which we don't support, or you don't want to implement it within CGRateS, you can feed CDRs over various APIs which we open, and that includes JSON over socket, JSON over HTTP, JSON over WebSocket, HTTP REST, or again GOB. Regarding the CDR processing, this is how we have done it today. You can see on the blue part is the input of the CDRs. So you can, as I told you, from CDRC, which we call CDRC client. CDR client, we can feed in file CDRs or offline CDRs. We can also do it via what we call session manager. This is the one interacting with the switches. It's able to like steal CDRs out of events. And another example is the diameter server feeding CDRs into the CDR server. These CDRs will be sent to various components which we have. As I told you, we can communicate over internal APIs, or within the process, or we can do it over external ones. So these components can be spread over different servers. They can become daemons by themselves. So you can scale up a lot by using this approach. So you do aliasing if you want to replace various things inside your CDRs, or you grab the user profile. This user service is something which puts together various user properties. So if things are missing from your request, for example, in user sending an SMS, you cannot tell whether it's a prepaid or postpaid. You cannot tell, you just have a CDR record. So you can only tell the CLI and the destination. So based on user service, you can grab whether it's a prepaid or postpaid, whether he has different pricing than normal, and so on. Then the RAL is the rating and accounting component. There is where the rating happens. There is also where the accounts are kept, the wallets, the bundles. And if you want, but we made this optional, you can store the CDR into our storage or not. And the last part, you can send the CDRs again to CDR stats to produce stats for you like ASR, ACD, and so on. So once we are done with internal processing, we will pass it to the replicator, and this replicator is able to pass the CDR to any number of hosts you have. The advantage of this approach is that we don't need anymore to provide any SQL schema to you. You can optimize the storage in the way you need it. If you want to storage on Amazon or wherever you want, you can do that. And the point where the CDR reaches here, it's already rated, and it's close to real time. If you use a generic interface to feed the CDRs, you end up with a very fast CDR processing, and it works like in-memory queues. So you get no touch with the disk, and it takes few milliseconds between you feeding the CDRs unrated and having at your HTTP server rated already. So that was really lightning talk. Thank you.
Regarding CDR mediation, as you commented, one common issue that we need to solve, I mean generally, is, for instance, you have the real-time rating prepaid, but you have several components in your network that are generating CDRs for the same call. For billing assurance, you need to correlate somehow those CDRs. This can be done using CGRateS.
Yeah, well, as I showed you, the CDR server is centralized, so the CDR server will not notice whether you receive a CDR or two, or where are the sources. So it will be fed like normal events from all over the place. It doesn't matter whether it's an offline CDR or it's an online CDR. They will just hit one by one and processed in the CDR queue. So normally you bin them there.
Okay, but you mean that you will bill CDRs that correspond to the same call as independent CDRs?
Well, yeah. Well, if we think about coming back on events, if we talk about events, it's the same story. The RAL component, the one which I showed you on top, receives the events from Session Manager, then not from the CDR server. And it will, in that point, compare it again as independent. So you can get events from the same call or simultaneous calls as the demo which I showed you today. They are simply parts of the call. They don't need to be full call. They are just parts.
No, that's not the issue. What I mean, one scenario that is quite common is you have rated a call in prepaid. So you have, let's say, the CDR that CGRateS is generating, and then you have another offline CDR from another network component that has handled the same call.
Okay.
And you need to process that CDR to know if the call was billed or not.
Yeah, well, we use unique accounting IDs, and we detect if we need to double the processing or not. So we don't bill the same CDR twice, because each request has a unique ID. Each CDR, actually, each call has a unique ID. So if we have done already it in the Session Manager, we cannot put it in the same way on.
Okay, is configurable the ID that you can use?
Well, you can feed it. You can feed in over APIs.
Okay, perfect.
So, okay.
Thank you.
You're welcome.
Okay, then thank you, Dan. And,
Thank you.
Let's get